Okay, let's dive into this. Because right now, we are living through a massive, fundamental shift in how software is actually created. It's a shift that's practically breaking one of the most critical parts of the entire development pipeline. Welcome to this explainer, where we're going to unpack exactly what's happening to code review in the age of generative AI.
So here's the core dilemma we're all facing today. AI coding assistants are generating code faster than ever before, right? And it feels like absolute magic when you're writing it. But what happens when AI is suddenly writing more than half of your code base, and humans still have to sit there and review every single line? Well, you get a massive, unmanageable bottleneck. Human reviewers simply cannot keep up with the speed of machine generators. It's just a numbers game.
Section 1, the AI code tsunami. To really grasp the sheer scale of this problem, we need to look at the undeniable volume of AI-generated code hitting repositories right this second. It is literally a tsunami.
Check this out. Meta recently dug into their internal data and found something completely staggering. Over the last year, the significant lines of code per human-landed diff jumped by over 105%. And at the exact same time, the actual volume of diffs per developer rose by 51%. So what's driving this? Well, over 80% of that massive growth is attributed directly to agentic AI assistants. The cost of creating code has absolutely plummeted, which means the supply has just skyrocketed.
And this isn't just a meta phenomenon. GitHub's Octoverse data proves the entire globe is going through this exact same surge. I mean, we're looking at more than 986 million commits in 2025. That's a 25% year-over-year increase. By May, monthly pushes had already topped 90 million. Plus, we now have over 1.13 million public repositories importing generative AI SDKs, and half of all open-source projects have at least one maintainer actively using an AI coding agent. Generative AI isn't some quirky experiment anymore. It is rapidly becoming the core infrastructure of software development.
But here's the catch. Because the rate of code creation is rising way, way faster than our human capacity to review it, the entire system is backing up. Organizations are watching the percentage of code divs reviewed within 24 hours actively drop. In some large teams, thousands of pending reviews are just sitting there in limbo. Our human attention is strictly constrained by the hours in a day, and relying on people to read most of these AI-generated diffs, it just doesn't scale anymore.
Section 2, the quality paradox. This brings us to what might be the most fascinating contradiction in modern software development. It's the difference between the vibe of AI code and the actual reality.
Now, what's really interesting about this slide is the massive, undeniable gap between how this code looks during review and how it actually performs in the real world. According to the New Relic 2026 State of AI Coding Report, an incredible 94% of tech leaders rate AI-generated code as higher quality than human-authored code during the review phase. But once that code actually ships to production, 78% report an increase in production incidents. So it looks fantastic on paper, but it totally breaks in the wild.
The runtime reality is honestly pretty harsh. 86% of organizations are reporting that their senior engineers are spending way more time firefighting. 74% say that a quarter or more of their AI-generated code requires significant rework, and 82% have hit at least one production failure tied to AI code in just the past 6 months alone. So what's really happening is your highly paid senior engineers are being forced to act as AI code janitors. They're literally diverting up to a third of their week away from building new features, just to triage and clean up unvetted machine output.
So the crucial point is understanding exactly why this contradiction even exists. It basically boils down to the difference between the source and the trace. You see, AI coding tools generate code based on the artifacts a human reviewer can easily read. The source. It looks clean, it's well-structured, it's consistent. But AI models are entirely blind to the trace. They can't see the runtime behavior under real user load, the weird edge cases, or the tangled web of complex dependencies. Reviewers are out here grading readability, but production? Production tests actual behavior.
Section 3, the security blind spot. This disconnect leads us directly into a severe issue because the consequences of trusting the source over the trace are incredibly dangerous, especially considering that 62% of tech leaders trust AI code enough to ship it without line-by-line verification.
To see just how dangerous that blind trust is, let's look at this data from IOActive's security study on AI-generated code. When developers ask AI for code using natural language prompts, the results for infrastructure and configuration are frankly terrifying. Docker files generated by AI have a 97.8% vulnerability rate. Let that sink in. Almost every single one is flawed. JSON configurations sit at 90.7%. Groovy scripts for Jenkins CI/CD pipelines hit 78.5%, and Terraform infrastructure code is at 71.8%. Leaving DevOps automation blindly to AI is just a massive security crisis waiting to happen.
IOActive actually tested 27 different AI models across more than 19,000 code samples. And here is the most alarming takeaway from all that testing. AI models virtually never refuse to generate code. They have a 0% refusal rate. Even if they have absolutely no idea how to securely configure a database or write a secure authentication pipeline, they will confidently hallucinate exploitable code and hand it right back to the developer with a smile.
When you combine that wild overconfidence with a total lack of human review, you get a highly predictable set of production failures. New Relic actually identified the top 4. Integration failures hit 31%, compliance issues at 30%, data integrity problems at 29%, and newly introduced security vulnerabilities at 28%. AI code doesn't just break production in one massive, obvious way. It breaks it in a dozen small, simultaneous ways all across your stack.
Section 4, Scaling Reviews Safely. So we've got a tsunami of code, a highly deceptive quality paradox, and a gaping security blind spot. How on earth do we fix this? Let's pivot and talk about how organizations can bridge this gap and scale their review process safely without just throwing away all the massive productivity gains of AI-assisted development.
And this brilliantly illustrates a potential blueprint for a real solution, Meta's Radar system. Radar stands for Risk-Aware Diff Auto Review. Rather than trying to lazily automate every single review or swinging the pendulum back to relying totally on humans, Meta built a smart, risk-stratified pipeline. It targets the low to medium complexity code diffs for automation, and it explicitly routes the higher-risk, dangerous changes right back to human reviewers.
Let's move to and see how this builds through a really strict multi-stage funnel. First up, you have eligibility gates, basically checking the author and the source type. Next, static heuristics check for obvious, immediate blockers. Then, a machine-learned diff risk score calculates the actual probability of a production incident. If a diff passes that, it goes to an LLM-based automated code review, which reads the semantic meaning of the code to catch subtle logic errors that simple pattern matching completely misses. Finally, deterministic validation kicks in to ensure it actually builds and passes tests.
What makes this system so incredibly powerful is that it is highly tunable. By adjusting the diff risk threshold, say relaxing it, so that the safest 50% of diffs are eligible for automation rather than just the safest 25%, Meta achieved a massive 60.31% automated approval rate. They were able to effectively tune the system to balance exactly how much automation yield they wanted against the strictness of their safety requirements. It keeps that massive code volume flowing without constantly breaking things.
And the data here is just the ultimate payoff. For hundreds of thousands of diffs reviewed by Radar, the median time to close a review was reduced by over 330%. Huge win for speed. But what about safety? Well, the production incident rate for Radar-reviewed diffs was amazingly low. We're talking just 1/50th of the rate of standard human-reviewed diffs. By routing the simple, low-risk AI code into a strict, automated funnel, they drastically reduced the review bottlenecks while actually improving production safety overall.
That quote right there perfectly summarizes the core takeaway from Meta's research. You simply cannot solve an AI-driven scale problem with human-driven manual labor. It doesn't work. But you also can't solve it with blind trust. Systematic observability, intelligent risk scoring, and layered automation, that combination truly works to solve the code review crisis. Which leaves us with one final, pretty provocative question to consider. The data is crystal clear. The AI coding era is here, and it is moving incredibly fast. But the gap between how code looks and how it actually performs is wider than ever before. So, will your organization build the observability loops needed to close the gap between the source and the trace? Or will you just let the bottleneck burst, leaving your senior engineers to spend their days as AI code janitors? Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.